Hello everyone, let's begin our pharmacological experiment. In this experiment, we will select of analgesics. In our pharmacology class, we have studied some analgesics, such as opioid analgesics, such as NSAIDs, non-steroidal anti-inflammatory drugs. And we know pain is an unpleasant sensory and emotional experience felt as a result of the brain's response to the damage, response to the disease, or response to the injury. Pain is subjective on the basis of objective. Pain is a specific sensation independent of touch or other senses, having specific central connections. We know in our body have some pain receptors, such as opioid receptor, and also have some pain transductors. For example, we studied NSAIDs, analgesic, antipyretic, anti-inflammatory drugs, and we know pain transduction is to transfer the signal of pain injury into internal biochemical stimuli, such as prostaglandin, bradykinin, serotonin, and cytokines. They act on opioid receptors to generate pain impulse. Among these pain mediators, prostaglandin are more important because prostaglandin can not only trigger receptors themselves, but also sensitize them. They are hyperallergenic to mechanical and chemical stimulation, apparently resulting from a lowering of the threshold of the polymodal receptor. In this class, we will use two methods to observe the drug's analgesic action. The first method, we will use chemical method. So the first experiment in this part, we will observe the analgesic effect of PE with writhing response method. The experimental principle is acetic acid is infused into mouse abdominal cavity. Intraperitoneal injection acetic acid. We have mentioned acetic acid. Acid is one kind of pain mediators will stimulate peritoneum to produce persistent pain, which causes the mouth appearing writhing response. So the writhing response means that is abdomen, inner fovea, and hand limb synthesis fundament turning forward. So let's watch a video. What's meaning of writhing response?
Observe the mouse response to the analgesic by torsion body method. After intraperitoneal injection of acetic acid to the mouse, the acid stimulates the peritoneum to produce the persistent pain, which causes the mouse to show the phenomenon of torsion body. It means that the abdomen of the mouse is concave, its trunk and limb are stretching with a high hip. Generally, after the administration of analgesic drugs, 20 minutes later, inject intraperitoneal 0.6% acetic acid solution, 0.2 milliliter, to each mouse, and record the time when injection is finished. Then observe and record the number of mouse torsion body within 15 minutes after injection of acetic acid solution, and compare the numbers of torsion body, the extent of the reaction of the mass between the groups.
Okay, let's continue. Just now we watched the video about the writhing response, and we have known this position. that is abdomen inner here, forward, and hand limb synthesis fundament turning forward. This position, we call this resting response. So let's study the experimental principle again. When we inject acetic acid into mouse abdominal cavity, we stimulate peritoneum to produce persistent pain, which causes the mouse appearing resting response. And we can calculate the resting response, the number of resting response. We can know the drugs has or doesn't have analgesic action. Okay, let's do the lab. In this experiment, we will use little mouse as our experimental animal. Mouse of Queen's species weighing about 28 to 32 grams. So in this part, don't forget, we should take 3 in each group. We should take 3 bigger mouse as your experimental animal. Why we use the bigger mouse as our experimental animal? Because the bigger mouse means the mature mouse, and because the mouse abdominal membrane is matured, so we can use and sensitive to pain. So in the first lab, we use the 3 big mouse, little mouse as our experimental animal to observe the resting response. And in this class, we use 3 drugs. The first drug is the tested drug, and we don't know the drug's name. We give the number, give the name is PE. So later, we will test the PE has or doesn't have analgesic action. And the second drug is morphine. Morphine we have known it is the prototypical agent in opioid receptors agonist. And morphine is the strong opioid receptor agonist. Morphine mainly acts on mu opioid receptor, and its analgesic duration is about 4 to 6 hours. Morphine is used to relieve pain after surgery, pain associated with trauma, cancer pain, pain from kidney stones, back pain, cough, and so on. So we have known morphine is the strongest analgesics, one kind of strong analgesics. So in this part, we will use morphine as the positive drug, and later we test the PE, the numbers of PE, the numbers of resting response in PE group compared to the numbers of resting response in morphine group, and we can know PE has or doesn't have analgesic action. The third drug is 0.6% acetic acid. Thus now we have explained with intraperitoneal injection acetic acid can induce serious stimulus pain, and we use this drug in this experiment. So these are our experimental drugs, such as this is acetic acid. This one is N-S-normoxylin, and this is our tested drug. The drug's name, we give the name is PE, and this is morphine. We know it is the opioid receptor agonist, strong agonist, have strong analgesic action. Okay, let's do the lab. Let's take the drugs. In this lab, we will use these drugs, acetic acid as the pain mediator, normoxylin, and this is the PE. it is the tested drug, morphine, positive drugs, some injectors, PE, normal saline, morphine, and acetic acid. And this one we use to give the color of the mouse. So each group take 3 mouse as your experimental animal, and let's weight the body weight. A little bigger mouse. Okay, let's do the lab. The first step, each group take 3 mouse as your experimental animal and use the baric acid, use the yellow solution marked first one, the second one, and the third one after being weight and the body weight about 28 to 32 gram. The first mouse as the negative control group. Later we will give normal saline as the negative control group. And the second mouse we will give PE, and it is the tested drug. The third mouse we will inject morphine, and we have known morphine has the strongest analgesic action in this part. So this mouse as the positive control group. Before we use the drugs, let's take the body weight and then intraperitoneal injection acetic acid. Inject these different drugs. The first one we inject normal saline, and second one inject PE. The third one intraperitoneal inject morphine. Okay, let's do the lab. Just now we have taken 3 mouse as our experimental animal. So the first mouse we will give normal saline. Each 10 gram, 0.1 milliliter. So take the mouse. Next one, we will use PE. We will test the PE's analgesic action in this experiment. Prepare the drugs and the injectors. The third one, we will give opioid strong agonist morphine as the positive versions. Okay, just now we have prepared the drugs. Now let's take the mouse. This is the first one. And we have used the baric acid. This one is the yellow solution, stained to yellow. This is the first mouse. And subcutaneous injection. Do you remember how to subcutaneous inject the drugs? We use the skin under the skin, and we use this neck skin subcutaneous injection. Okay. So at first, use your 2 hands to arrest the mouse. And your hands from the thumb, forefinger. Here is a triangle, so inner cavity. In subcutaneous inject the first drug. Okay, this is the first mouse. When you finish, put it back. This is the second mouse. We still use subcutaneous administration method. Inject, this is the test urgence, PE. Okay, let's inject PE. Excellent. Thus now we inject PE and put the mouse back. The last one, the third one, we stain the yellow into the yellow, and we have known this is the last one, the third group, as the positive group. And we will inject morphine. It's 10 gram. We give 0.1 milliliter. So this mouse, we inject nearly 0.3 milliliter morphine. And then put the mouse back. Okay. Just now we take 3 mouse. The first mouse as the negative control group, and we take the body weight 31 gram, and each 10 gram we give 0.1 milliliter normal saline. Subcutaneous inject 0.31 milliliter. The second mouse 31 gram, so we give 0.31 milliliter PE subcutaneous inject. And the third one, we give morphine. We inject subcutaneous inject morphine. And this mouse about 28 gram, so we give 0.28 milliliter morphine as the positive control group. And later we will inject acetic acid. Before we inject acetic acid, we can know. When we inject acetic acid, we can know normal saline doesn't have analgesic action. So the numbers of writhing response in normal saline group maybe more than other groups, maybe 30 times, 40 times, 50 times. And the morphine we have known have strong analgesic action. So after we inject morphine, the numbers of writhing response in positive control group, the number will be reduced, lower than normal saline, maybe only 10 times. Compared to morphine, compared to normal saline, we can know PE has or doesn't have analgesic action. If the PE has analgesic action in clinic, we can use PE to treat pain. Okay. Let's continue the experiment. Thus now we have subcutaneous inject normal saline, PE, and morphine in different mouse. 20 minutes later, so we should wait 20 minutes because the drugs need 20 minutes to have good therapeutic effects. Each mouse would be intraperitoneal injected with 0.2 milliliter of 0.6% acetic acid to induce pain. So we wait 20 minutes later, and just now we have injected these drugs. If the drugs have analgesic action, will have analgesic action. And then we inject acetic acid, each one 0.2 milliliter. And then observe how many times each mouse writhing response in 5 minutes after administration acetic acid. Okay, let's do the lab. Okay, just now we have inject acetic acid, each one 0.2 milliliter acetic acid. Okay, have you seen this? This position, just now we have explained, it is the writhing response. So we need to calculate the numbers of writhing response in each mouse. All writhing response, 1, and this is morphine. So you can see no pain, no pain. And this is the PE, have obviously analgesic action. Resting all this one, normal saline. Yes, normal saline just now have sometimes a resting response. And PE also has resting response. Okay, normal saline, resting response. Because to pain, so to right 1, 2, we calculate the numbers of resting response in 15 minutes. Don't forget, maybe we need 3 students in each group to calculate each one's resting response, the numbers of resting response. Okay. One more time. Okay, one more time. And this one is a morphine, just now have one time. Have you seen? Okay, don't forget, write down the results. 1 resting response, don't forget. 1, 2, 3, 4, 5. So don't forget, calculate the resting response and write down your results. Okay, just now we have observed how many times each mouse resting response in 5 minutes or in 15 minutes after administering acetic acid. Okay, so the first one, the second one, and the third one. The first mouse, we inject normal saline, and we also know normal saline doesn't have analgesic action. So many times of resting response. This one in Chinese is it is the Chinese 正. And in China, we use this one means the 5 times. So 5, 10, 15, 20, 25, and 28. So in normal saline group, have 28 times resting response, pain. And PE also have some resting response. So 5, 10 times resting response in 5 minutes. And the third one, we inject morphine. This one also has resting response, but not very serious, only 3 times. So now from this result, we can know the resting response in different groups. Compare this one is the PE, our tested drugs. Compared to normal saline, the resting response, the numbers of resting response is reduced significantly in PE group. So that means compared to normal saline, PE has analgesic action. And then compared to morphine positive group, PE groups higher than morphine. So that means morphine's analgesic action lower than morphine. Okay. So in the first experiment, we use the chemical method. Abdominal cavity inject acetic acid. And then we calculate the numbers of writhing response. We can know PE has analgesic action, but its analgesic action lower than morphine. Okay, this is the first method. So now we have do the lab. Okay, take a break and let's do we use the second method to observe the analgesic action again.